Now another question we have now this one. For this setup we have to find out the magnetic field at point O. Figure shows the current carrying wire. Find the vector of the magnetic induction at origin for the coordinate system. Now see, for the straight wires towards the center O, the magnetic field is not taken into is taken to be zero. By simple Biot-Savart law, this is the point of interest, suppose P, and this is theta. This is the current I. Now, if this point of interest is nothing is on the wire, this angle, we know what is the formula for dB. It is KIDL sine theta by r square, where r is this distance. Now, if I take this P point somewhere here along the wire, the angle becomes zero. Since the angle becomes zero, magnetic field is also zero for the wires which are heading towards the point of interest. So for BMA, here the magnetic field is zero. Then we'll take AB, for which we have the formula Ki by radius, into 90 degree, which is the angle subtended by the arc. Then, as we know, for the any arc form, and for any arc, if the angle subtended is theta, the formula is Ki by radius into theta. So that is what I am using. Ki by radius is A, and angle subtended is pi by 2. Since it is rotating in the xy plane clockwise, the magnetic field will be inside a plane of paper, so I have taken as minus K. Now comes another quadrant, subtending angle 90 degrees, same, but radius is different, Ki by 2A, pi by 2, and it is also obviously clockwise as in continuation of this only, so I'll take minus K only. Now this comes on this comes out, this semi-infinite comes out. For semi-infinite, the formula is Ki by distance from the point of the wire, perpendicular distance from the wire to the point of interest, and that is radius. Okay, so multiply by Ki by distance into 1. That only I am using, Ki by distance, which is A, 2A into 1. Now direction wise, this current carrying wire is in the plus axis of Z, that is K, and the position of the point is towards the left of this wire, that is minus I. So that has been taken into consideration, K cross minus I. So Ki by 2A, K cross I is J and minus J. That's it. I have now simply added for total magnetic field at center. Initially it is 0, then Ki by A into pi by 2 K cap, plus third part is also this third part BBC, where this part is 0, this I missed, this is 0. Then comes this one, which I have calculated like this for the quadrant arc and the semi-infinite wire. So all these taken into consideration, 1, 2, 3, 4 and 5 parts. Okay, 1, 2, 3, 4 and 5 parts, where these two parts will not contribute anything. This curve, this arc and this straight wire will contribute. That only we have got the 3, 1, 2 and 3 terms which are contributing, and 2 terms which are not contributing. So now formulas I have written. So for the first quadrant, this is Ki by distance into angle subtended pi by 2. For the second quadrant, same formula, Ki by distance into angle subtended pi by 2, or I've written here 2 2s are 4, so let's get solved. And then Ki by 2A, again we are saying finding same formula. Now I have taken Ki by a common, what is left is pi by 2K, you can see that, and another is pi by 4K, so these two can be added, and one is J by 2, or that I've taken I've taken LCM, so I'll get 3 pi by 4 K cap and J by 2. Then I'm taking pi by 4 as taken outside, the 4 2s are 8. I've taken pi also, and we got 3 by 2 K plus J upon pi. And that's the answer to the question. If you have any issue with the calculation, please do it yourself. You just need to add these 3 actually, rest are 0. If there's any issue in calculation, please do it yourself. You just need to add these 3 calculations of A, B, C, D and D, E.